Hey guys, welcome back from spring break. Today we're going to talk about the properties of radicals. So if you'd like, you can either print out 60A, which is on the HyperDoc, or you can just get lined paper and take notes and just try to keep along. So at any point, I want you to stop the video and try some problems on your own and go back and compare. Always go back and check your work and see how you're doing. Okay, so try some on your own. Don't just take notes. Kind of mix it up a little bit. So anyway, a radical expression in simplest form is in the if the following conditions are true. So there needs to be no perfect square factors. Okay, remember our perfect squares would be 2 squared would be 4, 3 squared would be 9, 4 squared would be 16, 25, 36, 49, and so on. Those are all perfect squares because we can represent it as 2 squared, 3 squared, 4 squared, 5 squared. Those are all perfect squares. Okay, we can't have any fractions underneath the radicand, so you never want to have something like that underneath the radicand. And no radicals appear in the denominator of a fraction, so we're not going to have anything that looks like that. Okay. All right, so we start out and we want to learn how to multiply radicals. So all we have to do is multiply the numbers under each of the radicals together first, unless they're perfect squares, and then simplify. Okay, so if I look at a radical 3 and radical 18, neither one of those are perfect squares, so I'm just going to multiply 3 times 18 and I get 54. Okay, so is 54 in simplest radical form? Well, remember from our last lesson, you can represent 54 by saying 9 times 6. Okay, 9 you can represent by 3 times 3. There's our prime factors. And 3 times 2 for 6. Okay, so when we find our pairs, because remember our index here is 2, we're looking for our pairs. We've got one pair of 3's, which would be right here, that would go on the outside, and then we don't have any other pairs left, so 3 times 2 is 6, so that would go underneath the radicand. Okay, so we would get 3 radical 6. Okay, so looking at number 2, all right, I've got 5 and 30. I've got radical 150 if I multiply them together. Okay, if I want to start to simplify, I could say 10 times 15 and 5 times 2 to get our prime factors. And then I've got 5 times 3 for 15. All right, looking at our pairs, we've got a pair of 5s, so we're going to pull that out. Okay, that means that 5 times 5 or 25 is a perfect square factor. And then what's left would be 2 times 3, which would be 6. So we get 5 radical 6. Okay, now for the number 3, you could do it 2 different ways. You could either say, oh, well, the square root of 4 is actually, that's a perfect square, so that's really 2. And the square root of 25 is 5, so our answer is 10. Okay, so we can stop right there. Or if you had done it the other way, okay, got radical 100, you could have done 10 times 10, 5 times 2, 5 times 2. And when you did that, okay, you notice you have a pair of 5's, so the 5's would come out, and then a pair of 2's. And that's how we would also get our 10. Okay, but the first way is easier because we recognized that they're both perfect squares. Okay, so if you have a number before the radicand, then you just take this number, which is -3, treat it like a coefficient. So in this case, there's just a 1 here. -3 times 1 is -3. And -2 times radical 2 times radical 4 would be radical 8. Okay, so then we can look at it like this and say, well, this would be 4 times 2, and then this would be, okay, oops, actually an easier way to do that one. Let's go back. Let's go back and do this one a little bit different. Okay, notice this example. Radical 4 is a perfect square, so let's treat it like this. The square root of 4 is 2. And now we can just say -3 times 2 is -6 and radical 2. That's a little bit easier to do it than the way I was thinking. Okay? All right, so we've taken all of these radicals and we've multiplied them together, and then we've simplified. Okay, at this point, why don't you go ahead and pause the video and try 5 through 12 and see how you do. Okay, the key is posted out on the HyperDoc, the link, but you can pause the video here and then come back and I'll just write the answers down for you. So for number 5, you should have had 5 as your answer. Okay, 6 If you did 90, maybe you did 9 and 10, 3 and 3, 5 and 2. Again, I'm going kind of fast on this because you can actually go back and look at the key. All right, so you should have done these by yourself. Pair of 3s, and then you have 5 times 2 left, so you got 3 radical 10. Okay, this would be 2 times 4, which would be your 8. Okay, negative 9 squared would be negative 9, radical 9 times radical 9, which would be 3 times 3, which would be 9. Okay, going on, you've got radical 18. So you could have 6 and 3. This would be 3 times 2, and this would be 3. So you would be left with a pair of 3s, radical 2. Okay, here we've got radical 50 if you multiply them together. So you could say 2 times 25 and 5 times 5, pair of 5s with your radical 2 left over. Okay, and then we've got radical 81 here. So the square root of 81 is 9. And this would be just 2 times 2 because they're both perfect squares, which would be 4. Okay, all right, so now we want to move on to adding and subtracting radicals. Okay, so to simplify we're going to simplify each radical and then combine the coefficients on like radicals. So think of like radicals as being like terms. Okay, so if I had 2 radical 2 and maybe 3 radical 2, I could add them together. Okay, 2 plus my 3 is 5, and the radical 2 would stay the same. But I could not add 2 radical 2 and 3 radical 3. Okay, notice they're not like radicals. You have radical 2 and radical 3. So our example in number 13, the radical 2's are the same. So all we have to do is look at the coefficient before the radical. We still call it a coefficient. And we say 2 plus 6 is 8. And then the radical 2 would stay the same. So it stays pretty easy. Okay, if there's no coefficient before the radical, it's really a 1. So 1 minus 6 would be a negative 5. And our radical 5 would stay the same. Okay, 2 radical 6 minus 5 radical 6. Okay, 2 minus your 5 is negative 3, and then radical 6. Okay, so again, at any point, if you want to pause the video, if you're taking notes, I want you to stop and write them down and then try them. Okay, all right, so let's try 16, 17, and 18. So pause your video here and try the 3. And now when you come back, you should get your answers. Okay, so 2 minus 8 is negative 6. 7 minus 1 would be 6, and our radical 3 would be the same. And then 1 plus 3 is 4, radical 7. Okay, here number 9, we're adding 3 and 9, we get 12. Okay, 1 minus, so this would be, whoop, these aren't even like terms, so we're going to actually go back and try to simplify them. So let's start out with our radical 12. And our radical 12 in simplest radical form, we've got 3 and 4, and 2 and 2. So for radical 12, we can write this as pair of 2's, radical 3. And then our 27, we can say this would be 3 times 9, and 3 times 3. So we've got 3 radical 3. So this would be the same as 2 radical 3 minus 3 radical 3. Now we have the same radicand, and we've got 3. So this would be 2 minus 3 is negative 1, or negative radical 3. Okay, and 6 would be 3 and 2. Okay, and 24, we could say 8 times 3. 8 would be 4 times 2. And 4 would be 2 times 2. Okay, so here for radical 6, we really don't have anything, so it's radical 6. And then for our pair here, we've got, this would be minus 2, and then radical 6. Okay, so this would be a 1 coefficient. 1 minus 2 would be negative 1. Okay, radical 6, or we just write this as negative radical 6. Okay, all right, so go ahead and continue trying them, and I will put the answers up. Okay, we have a lot of examples here. So again, go back for the detailed explanation. You can go to the key, but you should have 6 radical 3, radical 2, 11 radical 6. Okay, 25, you should have 7 radical 3. 6 radical 10 for 26. And for this one, when you simplify it all out, you're going to end up with radical 5 plus a radical 2. Okay, so now going back and reviewing, this is just simplifying each radical or cube root. So this is a little bit of review. Okay, so we're going back to our last lesson. Again, if you did not do the optional HyperDoc lesson for spring break, you might want to go back and make sure you understand everything in it. Okay, so we are continuing to use it a little bit. So we simplify the radical for number 1. Okay, remember we look at the coefficient piece. In this case, you got 3 and 3. So the number piece would be the 3 would pull out, and then for our variables, because we're finding the square root, the index is 2. We have 2 pairs, so x squared, and then we have a leftover x on the inside. Now for our y's, we would get 1 pair of y with 1 left over. So our answer would look like that. Okay, for 50, we look at the number. We've got 5 and 10. 10 would be 5 times 2. Okay, and we look at the number. So we've got a pair of 5s that gets pulled out. A 2 is left on the inside. Okay, and then for our variables, if we have 4 m's and we're looking for index of 2, it would be m squared. And then n cubed, we would have n and then 1 left over. So it would look like that. All right, so trying going forward, now we have an index of 3. So there's our index of 3. So instead of looking for doubles, we're going to look for triples. Okay, so 2 times 64. Then we've got 2 times 32. I'll go 8 and 4. Okay, so this is kind of a long one here. All right. Oof. Okay, so we got that simplest prime form there. So we're looking for our triple, all our triples, and we've got triple 2's. Okay, now I've got another set of triple 2's. All right, and then left over, I've got 1 2 that I haven't crossed out, so that goes on the inside. Okay, and I'm not going to forget my cube root. All right, my variables, if I have 7 x's, okay, we're looking for triples. 1 set of triples, 2 sets of triples, so x squared with 1 left over, and then y to the 6th. So we got 2 sets of triples, so y would be squared. So our final answer would be 4 x squared y squared cube root of 2x. Okay. All right, and number 4. All right, we're not going to forget about this negative 4. We're going to bring it down. 196, we can say 2 times 98. And then we've got 2 times 49, and then we've got 7 times 7. Okay, for the variable piece, so if we look at the numbers, we've got negative 4 times our index is 2, so we're going to pull out a pair of 2's and a pair of 7's. Okay, so we don't have any numbers that go on inside the radical, so for the variables, we've got a pair of x's, so there's just 1 x. And then y's, we've got 3 pairs of y's. So y would be to the 3rd power. Now we multiply to get the coefficient. Negative 8 times 7 is negative 56. X, y to the 3rd. Okay? Again, please pause the video right here and make sure you understand this. Okay? All right, so for 5 and 6, I want you to go ahead and try those and go back to the answer key and check it. And then for number 7, I want to explain to you how to go back inside the radicals. So what value can be placed under the radical symbol to make this statement true? Okay, so to put the 5 back in, we're actually going to square it times the 5 inside. So this would be 25 times 5, and the answer would be 125. Okay, so you take what's on the outside and you put it back in by squaring or looking at whatever the index is. So in this case, whatever goes in would actually be cubed times that 5x. This would be 3 cubed, which would be 27. X cubed times 5x. Okay, and so when we multiply out, we're going